So we're going to go ahead and get started with recreation of another object here. And I want to pay very careful attention to some arcs and some definitions. So if we're going to go to recreate this mug, this time I'm going to do right plane. I'm going to start with my key characteristic center line. You want to make sure that you have it not slightly off, but you want to make sure that you actually get it to snap to that relationship so that it actually goes through the origin as a coincident point and it's vertical. There's another aspect that we need to add in. So here, where normally we would do some kind of a box, there's a couple variations of this that we'll do. But this one, we're going to start actually with, instead of, I guess we'll start with piecing some things together from scratch instead. So we're going to take these and we're going to make a line for the base. This will be, now watch Professor that knows what he's doing dump the coffee all over his keyboard. Wouldn't that be a fun show? That one would be content flagged as not suitable for children, I suspect. All right. So right there, we're right at 70 millimeters. So this, it's going to go up. This is going to go out at a little bit of an angle. And the overall height, I'm going to say, is about 170 millimeters or so. And then we're going to come back horizontal to our tie back to our line here. Now this, I'm actually going to delete this one since I don't need that specific dimension. But we're going to do another feature here. We're going to have a set thickness that we're going to use. We've kind of talked a little bit about this, but there's a reason that we want to use it this way. So I'm going to go ahead and enclose this to make it an enclosed volume. Now I'm going to set dimensions, and at the top, so at the base about 70 millimeters, at the top about 90 millimeters. So this should be about 45. This should be about 35. So it's pretty close on that angle, not too far off. And then our wall thickness, it's going to be, since this is a double-walled vessel, our wall thickness is going to be on the order of about 4 to 4.5 millimeters. Same thing between these two. So here is an example. I'm going to do that again. Here is an example where we go to do a measurement, and instead of getting a linear measurement, we haven't seen a lot of examples of this yet. If you click one line and then click another line, if they are already parallel, you will get a distance between them. But in this case, they are not. So we need to be able to set an angle. And we want to set them at 180 degrees. So now these are perpendicular with a really large angle reference there. You can, once you have established that angle, another quick thing that we want you guys to at least know that you can do, so you can select that and then delete it, and it'll maintain that orientation. So you can use smart dimensions to move things around in a drawing without actually establishing all of the detail that you might otherwise have to work on. We're going to do the 4.5 millimeter thickness for this wall as well. Now we're going to do a couple other features that are going to involve the sketch fillets so that we capture as much of the detail as possible. For these, they're going to be a lot smaller. It's going to be maybe about a 4 millimeter symmetric fillet, maybe 5. Let's do 6. Yeah, this is right at a 5 to 6 millimeter. It's almost like I know what I'm doing. So 6 millimeter fillet, and up at the top, this one is about a 1 millimeter fillet. The angle, yes, the angle I set with smart dimensions. I'm going to show you some more examples of setting angles. We're going to work with ellipses today because I'm going to make you guys all guilty violators of copyrights by the company that owns all the things. So, and no, it's not Apple. You will come to understand in a few minutes. So we're going to come back to a lot more examples of angle, arc, details, etc. So this particular mug has an asymmetric where it's about a 1 millimeter, maybe a 2 millimeter fillet on the outside, and then about a 3 millimeter fillet, maybe just 2.5. 2.5 millimeter fillet on the inside. No, it is closer to a 3. And it's probably asymmetric on that, but that gets pretty close to the actual vessel wall. Turns out this is an ideal angle for the purposes of discussion. This is an ideal angle as fluid comes out of the cup. The form drag on the fluid tends to mean that this edge, instead of being a sharper edge as it ought to be, that means that the fluid wants to follow the path of least resistance here, the curve. And that means that it's always dripping stuff down the side of the cup because of their particular design. So it was an expensive cup once upon a time, could have been designed much better because fluid likes to separate cleanly from sharp edges, not from rounded ones. So that's why different shaped cups will pour water down the side of the glass instead of just over the spout. All right. So with all of those fillets set and all of that sketch detail set, we do have the ability to make some changes to these. You'll note that even though we've got a bunch of detail here, we don't really have a fully defined sketch. So again, we're always kind of chasing that fully defined sketch because of reasons. We want to be able to scale things and make things work really, really well. So here, what I can do is I can cheat and again, move the sketch with the smart dimension if I'm being lazy, which I am a little bit today. So I'll move my drawing up. Now I've got partial definition. Now I make a connection back to the origin, and my overall height for the cup should be about 170. So it's, pretty steep wall. This is why I haven't set an angle between the center line and this. So I'm going to show you real quick how that actually gets measured. So we click the center line. I've always been kind of curious about the particular angle of this cup. So by clicking somewhere along the line, not at a midpoint and not at another reference point or juncture you can get an angle between them. So it's very interesting. So a little less than 3.5 degrees. Yeah. I mean, seems about right. There's a couple other features in here that mean that's not entirely accurate, but it'll do for now. All right. So this we've now got fully defined because we've got our endpoint of the arc established as being a specific height from the origin. So now we've got our fully defined sketch. We can step back and we can do our revolve. And it's going to presume that we want this geometry because that's enclosed. We've only got one sketch, so software doesn't have to work very hard. And yep, that's actually about accurate because we have a closed volume. That thin feature is not selected by default, so that's good. So we do our revolve, and yeah, it looks pretty close. So this is one of the ways that we can use a couple of these tools to recreate a lot of the geometry or a lot of the peculiarities of an object, a lot of the dimensionally specific items to recreate it. There's a couple simplifying assumptions on this. In the real version, this section at the top is flat. This section down here has a base that's flat for a portion, so the actual angle is a little steeper, but not much. So this is close enough that you would be able to pattern a part on a 3D printer and get it close, because this is about the right external diameter and so on. So we can use a lot of this information that we gather, especially when we start manipulating angles and things, to change what that looks like. So if we go back to that base sketch and we say, all right, so instead of the relations the way we did them, we'll do some of the same ones. We're going to undo the revolve. We're going to undo a couple of those dimensional changes. All right, so we're going to go back up to this step where we've got, there we go, reorient our view again. So we're going to go back up to this step where we've just reset this to the origin. So this height, we're going to give a value. But first, actually, let's go back a couple more steps before we define the angle here. There we go. So if we wanted to use angle definitions in more of these, that's going to help. What this is going to do is this is going to create the capability for us to be able to set an angle either between these two lines as it is, or I go back into the mode and edit this sketch. There we go. So this dimension, maybe we actually want to set or specify the dimension here. So every once in a while, you're going to click a tool and it's going to do a whole lot of not much. So this 3.35, I want to say it was 3.35. So this one equally, we want to set as 3.35 to give us a reasonable baseline. We got a couple jumping in and out here. A couple are struggling with internet connectivity, which is always fun. All right, you back and alive? Hopefully. All right, so what we've got is we set these two dimensions to be 3.35 degrees. We can also bring this down out of the way so we can actually see what the dimensions are. So now these two lines are made parallel by these two angle references. So we're going to do that first. Then we can set the thickness between those two. So this one, we're actually going to force this, in this case, to be a driving dimension. If you know what you're doing, you can do that. You can set this. So yeah, let's do one more. This is another part of the reason why I'm doing a couple of these steps the way that I'm doing them. So I'll step back a couple there. So I'll zoom in so that it's as much of the screen as possible here. So what you need, for those of you watching on postage stamps and potato chips and whatever else they're calling electronics these days, I'm going to bring this down here and set. What you have to do is click somewhere on a line that's not the origin, not a midpoint of a line or some other key reference point on a line. You pick somewhere in the middle range. And if the two lines are not parallel, it'll automatically give you the default, or it'll automatically give you the default here for the angle. So 3.35 is now set. A lot of times it's going to move that dimension around on you. That's fine, just as long as you still have a definition. So again, pick a point on the line, pick another point on the other line that aren't right next to each other, and then set the angle manually. And then you can set the distance between these two, the actual thickness between those two parts. And because of a couple other features that I've added here, the angle definition changes whether or not I need some of these others. So by setting this distance and then the angle, and this distance and then the angle, I've kind of fixed both of these as long as this value has been defined. So we're going to look at how to make some changes there, because if I hadn't specified this dimension yet, then I should be able to redefine. So let's check this real quick. I should be able to now set the thickness without it being a driven dimension. So I'm going to set this as driving. And yeah, it's because of this line having both of those sides defined. I'm going to have to delete that one as well. Okay. 4.5. All right, so I can change those. I have the angles set, and now I can go back in and make some of the other changes. The smart dimensions give you some useful information, but a lot of times once you've gotten something like a set of parallel lines defined, you can come back in and delete one of them, and then you are no longer in an overdefined case because you've now got these two lines set as being parallel to each other using those angles. So you can delete one of them as a reference point to keep things from being overdefined. Then you can come in and make the movement to bring up this. So here we go. Let's do 0 as our definition. So this brings our base up to parallel with the origin, which is what we want to be able to control it. And then we can go in and start doing our sketch filleting like we were doing. So each of those two has about a 6mm fillet. This one, that one as a 1mm. It's fine. And then this one was our 2.5. We'll make it real entertaining and do a 3, which is about the limit of what this will allow us to do. All right. So now the only thing we have to come back in and do is really set the height. We could do it based on a couple other parameters, but what I'm going to use is this top point, this end point of the arc. So I'm going to use the outside arc this time and say this in total should be right at 170. So now everything else has moved. The only other thing that I need to set, because I don't have base diameter set, is I need to specify the other end point of that arc, the distance between that and the origin. So it's going to be a vertical distance. So that needs to be half of 90, which is our 45. So importantly, by grabbing those end points on that arc, everything else has to be defined because of the angle relationship and because this is tangent to that angle. That sets all of the references for everything else to close this geometry using angle reference. So same part, a couple different ways of approaching the dimensional definitions, and it'll work exactly the same when we go to step out of the sketch and do our revolve. It'll understand, hey, we're going to do a revolve with this volume. And again, we've captured most of the features of our particular object that we're looking at. So we can get a lot of detail set up in these 2D sketches, but it can be challenging to get all the right relationships. So we're going to go over some more key information there. So yeah, the difference between driving and driven dimensions is, let me go back to the sketch so that I can show that. The difference between driving and driven is right now, this arc has a radius defined at 6 millimeters. If I go to say, hey, I need the radius of this arc, because these lines are all parallel, these arcs themselves have a note here in yellow that these are already established as being in parallel. That's what these symbols mean. So because I already have the definition of one because of geometric proofs, which should make at least a few of you wince that had to do those, with one arc being parallel to the other, whatever the dimension of the first arc is, whatever that radius is, the second arc has to be the same radius. It can't be something else. So if I tried to make this dimension driving, that means that this dimension would now control both arcs. I would have to delete the other radius, or in this case, if I say I wanted this to be driving, let's take a look at what that would be. This relation. So I'm going to escape to get out of that tool. I want this relation, and I'm going to delete it. Now I could set this since this I set to be a driving dimension, they would automatically get to be driving, but that would change some of these features. So I could go all the way up to something like 12 on this. And now I have two completely different radii. So I could still have a revolved feature, but this is now driving. So if I hadn't added that, we currently still have that relation. I'm going to hit escape to get out of that tool. I'm not going to select that. I'm going to delete it. So right now, you can see that because we no longer have that specific relationship, that parallel relationship between those, now this is not fully defined anymore. So this, we could specify as 6, and indeed we would need to specify it as 6 separately without that parallel relationship. So that's why all of these little tiny symbols are so important, because it tells you what the software is interpreting about how you're creating the geometry you are. And so it seems almost like a meaningless, tiny little detail, but it actually turns out to be very, very important in order to get fully defined sketches, so that when you have to go back and make design changes, you can do them in a way that everything else will maintain the relationships that you want and intend for your design. Because in engineering, we often have very, very specific tolerances that things need in order to work correctly. So if not, then you end up with some in some circumstances, catastrophic side effects. So I'm going to go ahead and wipe that relationship out. And here we are back to our original sketch, our 3D object. Okay, so there's a couple other tools that we also want to make sure we know how to use. We've covered things like extrude base boss. We've covered revolve a little bit, so we've got a little bit of experience with that. We've kind of talked a little bit about extrude cut. We haven't really done a revolve cut, so we are going to go through kind of a detailed example of another way to do this same kind of thing using a revolve cut. But again, we're trying to think in terms of this side is additive in nature. This side is subtractive in nature. So this is like sanding, drilling holes, cutting stuff, etc., punching holes. This side is adding material, depending on what your process is. A loft is kind of like adding a clay form to something, or free form fiberglass over a skeleton frame or something like that. It's meant for connecting complex geometries to each other. So we'll get into that in much more gory detail later, because I may go ahead and have you guys build and recreate the centrifugal supercharger model, because that one's always a fun one. So make sure that you guys can do super complicated stuff like compressor or impeller wheels for turbos and superchargers and stuff like that, because that really pushes your SolidWorks skills and abilities hard. All right. So we've got a couple more things that we're going to look at as examples. We're going to start a new drawing first. I want to pause for a second and check for questions and points of major confusion and so on. Maybe a little early to do, we'll see. All right. So we're going to do another part here, and we're going to add a sketch. In this case, same kind of idea. I'm going to work from the front plane on this one. So we're going to cover using the couple other tools that we haven't really used extensively yet. One of the big ones is going to be the revolve cut. So let's take a look at how we might recreate the same shape, but using a subtractive approach. So the first thing we're going to need is pretty basic. And we're going to create a cylinder, which we do by doing this. We set our height. So let's do, sure, 180 millimeters. So if we were starting from some kind of bar stock and we decided that we were going to CNC machine our coffee mug out of a billet block of stainless, this is what it might look like. So this outer one needs to be a little bigger than what we need. So needs to be probably about 50. Yeah. So it needs to be roughly something like 100 millimeter diameter. All right. So we've got our sketch here, and I'm going to go ahead and revolve that. Okay, so we've got our bar stock now represented. One other thing that we want to do, there we go. I think Ben's connected and alive. Ben, you'll have to let me know how many total hours of sleep you're on today, because that's been my question check for the day. We've got, I don't think I saw it in the earlier block. Nope. Okay, 6. That's a reasonable number, not too egregious. All right, there we go. So we're starting with our billet block. We're looking at a technique, revolved cut. So what we need to do that is think of what material would we take away. So we have a block of material that's bigger than what we need, and now we need to add another new sketch. So this time I'm going to do it as a separate sketch. I'm going to define it as being on the right plane. So that way we can have maximum confusion and lostness. There we go. So here's our origin. And what we're going to do is we're going to add our base. So here you want to be careful not to associate it necessarily with the arc. You can, but it's something that you want to note that means it's going all the way up to the upper surface of the object that's already established. So I'm going to leave it just a little bit beneath the surface. Bring this down, bring this across and down. So I have an enclosed volume. Now we're going to set a couple details with smart dimensions, and you can do the same thing right now. We've already got a parallel relationship established. So we can set the distance between these. We'll do the same 4.5 millimeters and 4.5 millimeters. Then we're going to come in and do some of our sketch filleting. We're going to set our overall height after that. So for this one, we're going to do both these points. We established this was about a 6 millimeter fillet. I don't want the actual line. I want the actual point. There we go. So we're going to hit OK. So we have both of those radii. Note that we have that parallel relationship we talked about. So that's also very important. Now we need to know how wide the base is. So the base needs to be half of 70. Yeah. Half of 70 is what it was. So 35. And then the top needs to be about 45. Now we only have to set the overall height from the origin to that top line. In this case, I went ahead and let it grab the center line because that'll give me some useful information later. And the overall height needs to be 170. And I'm going to leave this sketch the way that it is. I'm going to go back to that base sketch and move our billet block up a little bit relative to the origin. So that'll make sense why in a second here, because otherwise I'll go to do an operation and it's not quite going to make sense. So I'm going to step out of that sketch. I'm going to go back to this sketch. The distance between this bottom rail or this bottom surface and the origin, because of its placement, I'm going to say this is 2.5. All right. 2.5 millimeters. That'll put our new sketch entirely inside this volume. So this is going to be using a subtractive method. I'm going to go back to edit this sketch. Now, if we were to just do a real quick revolve cut, what you would have is, and this one doesn't have the center line reference, so we need to fix that. So we're going to add our center line, especially when you're changing views rapidly. You want to make sure that you've got your orientation correct so that you're not zooming in and out at an angle and creating extra headache for yourself for no good reason. So we're not going to do any more dimensioning. We're going to do an example of a quick revolve cut based on line 8. The actual contours are what's enclosed by this area. So when we do that, we can see that we have, show you another quick technique here. We can see that we have our cutout. So this is our cross-sectional view. That turns out to be quite useful because we can take a look at what the interior of an object looks like. So we can see where material got cut away, where material has not, and what that looks like. So it turns out to be pretty useful as a view, but that doesn't do what we want. Any suggestions on how to fix that operation? What should we do differently or better? We're going to do a revolve cut. What's something else you might have to do? We'll go ahead and add our little fillets while you guys are thinking about that for a second. Do 2 millimeters here, 2.5, I guess is what we were doing. Any thoughts on how to do the revolve cut better? So that cut out what was in our sketch. If we were really using something like a lathe and we were turning this block on a lathe and trying to cut away everything that wasn't the cup, we would have to do the opposite of this because of the revolve cut, right? So what's the opposite? What we effectively did there was we created a mold for the cup, sort of. So we don't want to do that. We actually want to create the equivalent of what would be termed like a shaping die. So how many of you guys have actually seen a shaping die or anything like that before? Let's take a quick look. So a stamping die is the negative of a thing. It's the negative of, or the reverse of, whatever it is you're trying to do the operation on. So we have some kind of upper die and lower die. We have a sheet. So this is a material, whether it's plastic, whether it's whatever, and we apply the pressure and we stamp it. So if we're doing a subtractive method, we have to think more in terms of like the die and the mold side itself. So how do we create all those features? Well, we do that with this kind of an operation. We do the opposite or the inverse of whatever it is. So here they show a couple examples of some various dies. There's many thousands of them out there. Most of the products that you use are either injection molded or they're stamped out on a die in some capacity like this. So this is what we want to be focusing on, is how do we get the negative of the thing that we want? And the way that we do that is actually not by using this area, even though that's important. But what we actually do is we create, for instance, an outer, you can think of it as an outer die. And I'm going to reset my orientation here so that my view is actually correct. There we go. So see, even though it looked like I was creating a line that was parallel, if you don't pay attention to that view, you're really going to get into trouble. So we're going to come down. We're going to go out and around this geometry. And we're going to go up. I'll make that square here in a second or two. We're going to go up. And then I'm going to bring this down to make a point. Okay. So that should be enough definition that I can now step out of that sketch. I'm going to do another cut revolve. And I want that exterior region, and I want that all the way around. So now we have a little more familiar shape. The downside is what I have to do is now the way this cut it took out both the geometry I want and this exterior region. So I don't want to do that. I'm going to make an edit to this. And I don't want that whole region. I only want this outer region. So let's try that one more time and see. Nope, it's still making that fundamental geometric cut. So I'm going to edit that sketch again. And I'm going to bring this back down here. So this should give me oh yeah, that's what's going on. So let's delete this one and the one under that. And let's bring it to this edge here. There we go. I've got my reference points that I'm interested in. All right. So that region should be defined. Let's see. I'm going to make certain this is actually connected. It'll actually select the tool I'm looking for. I'm going to make certain that this is connected all the way up to the origin. All right. So that should allow me now to step out of that sketch and redefine which volume I'm looking for. So we're getting more of our features here. But I don't want this interior region of 2. I want this exterior region 1. Because of how I've got this arranged, this is going to make a partial cut. I'm going to need to copy over that arc because of how this is working. So it might be easier. I may have to separately enclose this whole volume or in this whole area because of how it's trying to behave right now. So let me go back to that sketch and edit it because what it's doing is it's trying to grab both this exterior region and the interior region at the same time. And we don't want to do that. So actually, let me do it this way. Let me step out of the sketch. Let me delete this first cut revolve because what it's doing is it's taking away the material from the inside. And that's why it's showing up differently than what I'm trying to demonstrate for you. So this will be slightly more clear. Then I'm going to delete the second cut revolve after SolidWorks throws a conniption fit. All right. So there we go. Now I've got my exterior because I'd already set it up to cut that interior region, it was counting it as both, and that's not what we wanted to do. So let's go ahead and do one more operation. We're going to do another revolve cut, but in order to do that, we're going to need the second region defined on our sketch. So sketch 2. There we go. This interior region, we actually want to make an interior, and it needs to be at least a little bit taller. There we go. We're drawing things at an angle, which is always a no-no. It's bad engineer to draw at angles. A whole bunch of reasons why. So now this interior region is going to be our second cut, and you'll see why that makes sense in a second. So we've got our first cut, but it's still a solid block. So this would be sort of machining out the outside just to that upper edge. Now we're going to machine out the inside with this second operation. So we do another revolve cut based on sketch 2, because that has the other detail. And we want this interior region defined by all those features and a 360-degree blind cut there. So now it will make a little bit more sense. So same operation, but done using a subtractive method instead of an additive method. And so long as you're not woefully undercaffeinated, as I am today, it's a lot easier to be able to follow along, pay attention to those little tiny details. But I want you guys to see, as those come up, all the little fixes and struggles and how to evaluate and understand and troubleshoot what's happening to your model so that you understand how to fix it later. That way, when you're in an important board meeting or something, you can impress your boss and earn the big bucks. So hopefully you'll go back and catch why that troubleshooting method is so important. And as in real life here, this particular cup is empty, just the way the other one is. So what we've got is another approach to doing the same kind of thing. You just have to think about making kind of this one region, the outside, almost like a cutting or stamping die, and then the inside. So you capture the geometric features of the object you're interested in, and then you have a positive approach and a negative approach, depending on how your brain thinks most easily. But again, that's why I want screenshots showing how these things are working for you guys, what approach you're taking, how you're thinking about these problems, because that will help me better troubleshoot where some of the weak points are. All right, so we're going to do another one. And what I'm going to do is let you guys get a start on it and then see what can happen here. So I'm going to set you up for properly demonstrating your copyright violation, and you will see why in a second. All right, so we're going to start a new part, and I'm going to go ahead and pause while we set this up, and then we will get this up and operating again in a couple seconds. All right. So in order to properly dimension all of our copyright violations here, I'll start from the right plane just to be a cheeky little jerk. So we'll set this up, and this is going to be 2.5 inch. We'll set our base dimension down here to be 5 inch as a result. So now that one's fully defined. We're going to add in an ellipse, so not a partial ellipse. You could go there, but I'm going to recommend not for now. So we set an ellipse somewhere up here. We're going to do smart dimension to reposition stuff. So we have to set up a couple of them, and All right. So some of you probably have something kind of sort of like this and doesn't really resemble what you think it should. All right. So first key is we're going to use the smart dimension. So this, we're going to do a couple steps and I'll demonstrate kind of how you do things. So this side was 2.8 inch. This side was 2.5. See if I can get it. We'll lock on here. 2.5. There we go. Same deal here. We can set our dimensions after or before we move it. That specific detail is immaterial. 2.5 inch. .8 inch. All right, so I'll zoom back in. I have to remember you guys are watching on a postage stamp. Okay, so we've got our ellipses. Now we're stuck. So what do we do now? We need to move them, but how do we do that? We can use smart dimension, but how? Anyone figured out how to properly position them? Because we're going to have to go back to the drawing. How do we position them? Well, first, let's go back to the drawing. Okay. We're going to do some annotation here. So what do we need to know? We need to know a center point. And a center point. Okay, we got our two center points. We're going to assume symmetry because unless Mickey is talking to somebody, Mickey or Minnie are talking to somebody, the ears are symmetrical. Then they suddenly go all up on one side, do interesting, weird things. So now we need to know the distance between them. So that comes to about here and about here. So what's our distance? 1.5 inches by 1.25. So 2.5 by 2.25. Let's try that. But in order to go over and do the next one, we have to clear all this. Back to SolidWorks. So 2.5 inches 2.25 inches. Same thing here. .25 inch. .5 inch. There. So we've now got these two ellipses oriented more or less the correct direction. All right. Now, before our copyright violation is complete, we have to get rid of these overlaps. There we go. So, problem is, we don't have a fully defined sketch. So, what do? Anyone have any suggestions?
Sorry, can you show me one more time how you got rid of the overlaps?
Yeah, so that's using the Trim Entities tool. So you grab your scissors, and oftentimes it'll start with the power trim as the default. Most of the time, trim to closest is actually going to be your friend, because the power trim, what you can end up doing is this, and all of a sudden now, you've got not much of a drawing left. So the power trim is useful, but I tend to prefer the trim to closest because it's a little bit more precise. All right.
Sorry, I also have one more question. How do you make sure that the rotation of the ellipses is this correct? Sorry, I'm trying to figure out how to say it.
Yeah.
So it looks like mine, one of them is tilted a little bit too much one way.
So we will come back to that here in just a little bit for a few different reasons. The first of which is we're going to set that up, but I will give you a hint that what you're going to need is a couple of these guys. And then you're going to need one more here. So we'll go ahead and set that, but we'll do that a little while later.
So whenever I trim, my initial circle goes completely white, like it's no longer enclosed. Why is that?
So depending on this inner circle, the 5-inch one.
Correct.
So yeah, once we trim out those parts, that circle, depending on how it was selected, there are certain circumstances where you might have accidentally grabbed like the whole outer edge or something like that. You can always hit Control Z and go back a step or two and pay attention to what's highlighting orange. So
okay. Yeah, because it should just be that little one that intersects with the other circles, right on the inside.
Correct. Yeah, but so some of the time, especially using like a trackpad or something, right, you can end up with a very minor adjustment, or when you go to actually click, the trackpad moves, and then you end up cutting something other than what you intended. So that's why power trim is sort of disastrous. That's like using a Tim Allen version from Home Improvement of a chainsaw on your drawing, and it's just really goes bad very fast.
Okay, but I should be using the trim to closest, right?
Yeah, I would use trim to closest just because it's going to give you a little better precision control.
Yeah, so like I can see my entire circle. It's just it's not a solid, like it's white. I can see the background, but it's not going through where I trimmed. Like it did trim it. It just turned my, like the correct trim.
Yeah.
You get what I'm saying?
It may be that the two endpoints are not necessarily coincident anymore,
Okay.
or something like that. Because that could change how the circle is being defined.
Okay.
So that's another thing to look at. But if it's still causing you problems here in a couple minutes, we can take a look.
Yeah, I'll just keep working on it. Thank you.
So what we need to do now is to try and get these arcs fully defined. So we've already got their dimensions. So if we tried to specify, for instance, if we tried to specify this distance again here, that would be an over definition because it already knows what those are, right? Same thing if we were to try and specify those dimensions. So that kind of doesn't really help us. But what information do you guys think the arc needs in order to be correctly positioned relative to the origin? What do you guys think? We need to grab the origin and what? We can actually define these arcs with a single dimension. The most important are the endpoints. So you can do it either by the vertical or by the horizontal. Either way, you can get full definition because arcs need to know something about where their radius is and then where the endpoints are going to be. Those are the two major keys for any variation of arcs that are going to be used. So, but before we do that, if I undo that last dimension here, what we'll notice is if we grab onto this, we could have it tilted. Okay, and this is what we were discussing earlier. So how do I figure that out and how do I fix it? Well, you're going to need some kind of center line is going to be about the easiest way. You're going to use another smart dimension. And you want to say, actually, I want to change this angle. And you can change it manually to get to the angle that you want it to be. Maybe you want to start by getting it close to 10 degrees. And see, okay, maybe 10 degrees is not quite the relationship that we were looking for. So we go in, we edit that, and we say, you can also reverse the direction of that relationship. So in angles, that can start to matter because of different reasons. So you can do 15 degree, and you'll note again that this change in the orientation is enough to give it full definition. So we don't have to set the endpoint difference. You just have to be careful about which of those you're going to be able to use. So this is still not quite correct. So maybe about 20 degrees is pretty close. Let's do a sanity check and do the angle between these two. So 38.4 is what that one was at. So we'll set it to be the same. Yeah, because these heights aren't quite the same yet. So 38.4 degrees, we'll set it to be the same. So several different reference point types to get to the same fully defined sketch. But that's the easiest way I know of to reorient an ellipse relative to something else, which you're going to get a lot of practice in using, or when you go to do that French curve. All right, so we're going to pause there for a couple seconds and take some questions. So we're going to do a couple more things. We, of course, have to, in order to make this a full and complete copyright violation, we're going to need the quintessential object up here. So the question is, how do we go about creating that bow tie? Or I guess technically it's a hair bow, loosely the same geometry. Any idea? Maybe we'll use a center point arc. So triangle is a good starting point. So we can do that. So we could, for instance, we'll take a look down over here for a second. So we could take a look at what a basic geometry looks like. All right, triangle. Okay. How do we make it look more hair bowy? We could do something like a sketch fillet, right? We don't want it up there. We actually want it like here, except when we go to do something like that, it automatically trims our object here. So that's not quite what we're looking to do. So we're going to need the geometry, something like this. And then we would have to come in trim our entities. And now we have hair bow, TIE fighter. Depends on how much of a fan you are. And then we want to be able to create that on top. But we also want to be able to set and change some of the dimensions. So let's look at some of the dimensions first before we go to move it. So you need to be able to set how high it is. And if we wanted it to be maybe 32 even, it'd have to be the same deal over here, 32 even. So now that this was a circle, but it's now two arcs, it has a radius rather than a diameter. So you have to set them individually. So if we wanted it to be 13, actually now it'll go as overdefined because it's still treating it as a single one. So that's good. I feel like in an earlier version, somehow that was not always the case. It would start turning it into two arcs. Sometimes, oh yeah, because it's still, so there's still a relationship there. That's why if we were to delete it, that's what would give us our independent relationship. So that's a good assumption for arcs much of the time. So that was a good choice by their design team. Okay. Let's say 70. Let's do 23. All right. So one of the things you'll want to pay attention to is as you go to dimension these, there's going to be some things that you encounter kind of like this. So I wanted to get enough definitions on there that it's not fully defined, but yet you can't specify where this is going to go. And that's because of this collinear relationship. So if we got rid of that collinear relationship, then we could set this dimension to be whatever we wanted it to be.
Can you show me one more time how you did the triangles?
Yeah, so the triangles is pretty straightforward. I just took a couple of lines, so I'll make it sort of loosely parallel here. So a couple of lines. Here we go. Using the leader lines as references. So this is how you get the starting point for the triangles. And then you do some dimensioning after you've got this all figured out. You can also set the height for where it should be intersecting. And because this isn't quite in the center, let me see if I can get it to show you by how much. It's close. Yeah, there we go. So that's center point right now, even though it looks about right, because of how everything else is defined, that needs to actually land at go. That actually needs to be 0. And what that will do is that will break some of these definitions because it needs to be able to set these up based on the collinear relationship that still exists. Let me back that up one more time so that I can make sense of this for you guys. There we go. So this is now parallel to the midpoint, but we can see that we have some slightly different angles on this side. So even though the distance is the same, even though our distance here or our overall height is the same, there's some variation. So each side is not entirely even. So let's say maybe 9. And then here. So this again is going to give us too much definition. The other thing that we would want to check with is that this origin was indeed at the center. So you can do that by cross-reference. So 35.2, 34.8. So that's another part of our problem. So there's also a couple ways that we can do that, but really what it comes down to is it needs to be 75. Or it needs to be 70 total, which means this would be 35. So we're close, not quite there yet. So I'm going to delete that to reduce some of the headache. This is one of the ones that would create some problems with that. Sometimes they're a little annoying to delete because of some of the additional features that pop up with that logo. All right. Now the all important part. I'm going to delete that radius for now. So some of those features where the larger blue ball will show up on the dimension is great for manipulating and moving stuff in motion studies. Not so great for trying to delete the dimension because it gets in your way of selecting objects. All right. So this I don't need. I'm going to delete this. I'm going to move using our smart dimensions. So we can start by inverting that direction, getting an idea how close that is. Need just a little more than that. Okay, then move the center. And looky there. We now have the starting point for a bow. This is not done exactly the same way as it will be on that particular assignment, but will give you some sort of a reference point. So trying to define all four of those lengths is going to create some headache for you. So you're probably going to want to do a little bit of a different definition, because what happens to one is going to happen to the other. You may have to delete the collinear reference, just like I showed you. So there are a couple of things you might have to do, but that at least gets you a pretty reasonable starting point for turning this into a full and proper copyright violation. All right. So this is also an example that's given in the previous lesson from this week. So I'll make sure that gets uploaded. I'll try and upload this one as well. So I'm going to pause here for a second and see where some of the questions are.